Hello everyone, welcome back to the channel. So today we are going to talk about another interesting problem in the data structure and algorithm. So let me just quickly show you that problem statement, and we will talk about that problem in two different ways. One is basically something which we can first we'll try to get an answer to that, okay, and then we will see how we can optimize that solution to get the better space and time complexity. Okay, so let's go ahead and see the problem statement. So I'm using the problem statement from the lead code. Okay. So we can definitely use it, not a problem. Okay. So for now, just focus on the problem statement on the left hand side. So the problem statement we have is basically we have an array. So here you can see this is an example input array. And what is the expected output is basically the we have along with the array we'll get a target as an input, okay, and then we need to find the sum of two element, okay, that is giving the same as the target, and we need to return the index of those element, not the element which are adding up to the target. Okay, we have to return the index of that. Okay, so now let me go to the whiteboard and then I'll just explain. We can use this same array 2 7 11 and 15. Okay, or we can take any other example as well. So let me take one example. Let's say so the ask is we have an array which has elements like 1 3 7 9 and 2. Let's say these are the 5 elements, and the another input is target is 11. So let's say this is your input, and we have to find an element which are adding up to 11. We have to return that index. So in this example, this two element addition is giving an 11. So the index of that, we know that array index start from 0. So it's a 0, 1, 2, 3, and 4. So the return we are expecting is 3 and 4, right? So this is basically a basic problem statement. So now, if you get this kind of a problem statement in your interview, what we should do first? So first we should basically do the analysis, and we should ask the constraint to the interviewer. Okay, like the first question we should ask is uh, whether we'll have all number positive numbers in array or we may have a negative as well. Okay, so first of all, why this is important? Because it's very important to understand the problem statement and all the requirement, all the constraint. Okay, and then basically we should start writing the code. Now, what type of a question you are asking to the interviewer? Okay, from that interviewer will analyze your thought process. Okay, whether you are kind of doing or you are having an understanding of the problem. Okay, are you asking the right question? Okay, so that's very important. So the what kind of a question you should ask for this problem statement is in the array whether we may have all positive numbers or we may have a negative as well, right? So we may get an answer that okay, will have only positive number or only negative or a combination of that. Okay, we may get a kind of that, and accordingly you can start the logic. So that should be your first question. Now the second question is whether we will have always the addition found in that list or not. Okay, because what if there is a no there is no two element which are adding up to the target. Okay, whether that there is a case where we'll always get or not. Okay, so that should be the next question, whether we will always get the two element which are adding to 11 or not. Okay, then the third question you can ask is whether we'll have a one pair or we can have a multiple pair, okay, of output, okay, which are adding up to the target. So that's another question. So the third question, okay, we have seen. So basically, initially, at least you should ask this question, and then as we progress, if you find some other doubt in your mind, we should definitely ask. Okay, but with these three questions, your interview will able to understand that your thought process. What is your thought process? Okay, perfect. So let's understand. Okay, this is what we have to do. The next thing that we should do is basically about uh, understanding the test cases, like okay, what would be the input, what would be the possible output, right? So this is a positive test case we took where we have the element found, and then this is the index we are returning. Okay, so the next thing is we may have a list empty. So if the list is empty and let's say they give target as a 5, so what you should return? So in that case, you can say that, okay, you want to return null only. Okay. Now you may get a list has only one element. So in that case also we should return a null because, okay, even though we have a target as a, let's say 2 only, but we want an addition of 2 element as a 2 and not the one element as a 2. Okay. So in this case also we can return a 2. Okay. Then yeah, so this is basically three basic use cases or test cases is something we can think of. And then now we got some basic constraint understanding as well as some test cases. Now we should actually start writing the code. Okay, by this time you should always talk to the interviewer and get the constraint, ask the possible test cases, and then once you get all the understanding, then you should start writing the code. But again, before writing the code, okay, you should not basically start directly from finding the best optimized solution. Okay, so the first thing that you should basically start doing is get a working solution. Okay, so first target should be to get the working solution. Once you get the working solution, then you can think of how we can optimize it. Okay, so what we are going to do is for this problem statement, first we'll write a basic working solution. And once we get that working solution, we'll understand what is the time complexity we are getting it. If it is too much, we will see how we can optimize it and we'll rewrite that program with the help of optimized way of writing. Okay, so how we can do it? So just quickly, we can write that 1, 3, 7, 9, and 2. Okay, let's say this is the list and this is the target. So how we can do that? So the basic fundamental or basic idea we have is basically we need 2 element addition to be 11. So how we can simply do, maybe we can have a 2 loops, okay, or a 2 pointer method here we can use it, okay, where we can have a loop 1, okay. In the loop 1, we can take the element 1, and then in the loop 2, we can take the element, next element, that is 3, okay. And what we can do is we can do the addition of 1 and 3, that's a 4. Is 4 equal to 11? No, that's not. Then take the next element, okay. After 3 we have a 7, okay. 7 plus 1, 8 equal to 11? No, it's not there. Next 9, 1 plus 9, 10 equal to 11? No, it's not there. Next 2, 1 plus 2, 3 equal to 11? No, it's not. So that's how this is your first iteration. So if it is not giving you, then you can move your loop 1 to the next element, that is 3. Okay. Now for the 3, again we can just basically go through loop 2 will again go through from the next element like 7. Okay, 7 plus 3, 10, not. 7 plus 9, 12. It's not matching 11. 7 plus, 3 plus 2, 5, not matching 11. So again, 3 is done. So again, we can go to the next element of a loop 1. So what is the next element of loop 1? Is a 7. And then next element we have in the 9 and 2. So 7 plus 9, it's going above 11, not matching. 7 plus 2, 9, it's not matching 11. So again, this is gone. Okay, so we can take the next element. So next element we have is 9. So 9 plus 2. 9 plus 2 is 11. So this is matching. So we can get the index. So here, 9th index is 0, 1, 2, 3. So we'll get as 3. And index of 2 is 0, 1, 2, 3, 4. So that's 4. That's it. So this is something you can return. So this is the basic solution we can do it. Okay. So maybe let's first write this on the LeetCode, understand if it is passing all the test cases, and then we can go ahead and see the time complexity and your space complexity on the LeetCode, and then we can try to improve it. But this is the basically working solution. This is how we can get it. So let's do it. Let's go back and do it here. So I have already a second type of solution, but I'll just rub this and we can write the fresh one. Okay. Perfect. So this is a predefined class and a function. So we are getting, you can see, nums is a list we are getting and target number we are getting. So what we have to do is simply just use a for loop. So for x in range, I'm writing this code in a Python, but here we'll have an option to write the code in any other programming language as well. Okay, it's up to us which programming language we want to choose it. So here I'm choosing it as a Python. Okay, so let me write it. If you have any question, you can just comment. Okay, So let me write. So I'm using outer for loop where I want to loop till the length of the list, which is nums. So this is outer loop. Now I wanted to basically find a number that we want to search in the second list. So what I can do is a number to find, which is equal to target minus nums of x. Okay, so this will give a nums of x, which we are subtracting from the target. And then what we are going to do is in the next for loop for y in range. Okay, so here we wanted to start from the x plus 1. Okay, next element of x, and then the length of nums. Okay, and then here what we are going to do is if number to find is equal to nums of y. Okay, if this is matching, then what we need to do is we just need to return an array or a list, okay, where x comma y is an index. Okay, but if it is not matching, what you will do is we have to basically if it is not matching, we don't need to do anything. Okay, if it is not matching, what we have to do is come out of the for loop, or let me use the so if it is not matching for all the combination, what we have to do is we have to just return the none. That's it. Okay, so how the execution will happen, let me just quickly walk you through. So first we got the let's take an our earlier input, or we can take this as an input 2, 7, 11, 15. So for x in a range, length of this num, so we got x as a 2. Okay, not x is the index. Okay, that's a 0. So nums of 0, that is 2. So we are finding the another elements. How to find it? Target is here, target is 9. So 9 minus number to find is, sorry, 9 minus number of x is equal to 2. So 9 minus 2, 7. So number to find is a 7. So we are writing another for loop. So another for loop is the next element of that list, which is x plus 1. That means one index. So one index. So y is 1. So num of y, num of first index, that's a 7. So yeah, number to find is a 7. So 7 equal to 7, condition true. And then we are just, what we are doing is we are just simply returning the x comma y. Okay, so x is the index is 0, y index is 1. So 0 and 1, that we will simply return it. That's it. That's how simply it is going to do it. Okay, if it is not found in both the for loop, what is going to happen is we'll come out of this for loop and we'll return the none. Okay, but if you find it, we'll return it from here. Okay, so that's how this is basically a working solution. Okay, definitely this is not the best, because here if you see we are using 2 for loops. That means our time complexity is basically n square. Okay, even this LeetCode will also show you that. Okay, let me just now we are done with the writing. I'll just run this. So it's basically running against some test cases. So here you can see if I just scroll down a little bit, all the 3 test cases are getting passed. And if I just submit it, once we submit it, I actually go and show you the time complexity and how much time it is taking. So here, if you see the runtime, you can see is it's taking almost 937 milliseconds. Okay, it's a greater than 35%. So definitely it's not a best solution, because we are just more greater than 35% of the people. And if you see the memory, it is taking around 18 MB. Okay, so that's completely okay. We got the working solution. Now the next thing that we have to do is we have to think how we can optimize it. Okay, so here we are using a 2 for loop. So it's basically usually, if you guys know a little bit about the time complexity, so time complexity is basically if you use 1 for loop, that becomes n, and now here we have 2 for loops, so it's a n square. Okay, so now how we can optimize it? Okay, how we can optimize it? Can we basically reduce and do it in a 1 for loop itself? Okay, so let's talk about that approach. Okay, let me go to the whiteboard and we can talk about it here. So let's again take an similar array where we have 1, 3, 7, 9, 2. Okay, and the target is basically 11. So what we can do is, now we have 2 for loops we are using. One for loop is to basically move the pointer 1, another for loop is to move the second pointer. Okay, so how we can optimize it? Okay, we can basically try to use it 1 for loop itself. Now let's say if you use a dictionary, okay, we can use a dictionary to basically maintain some kind of a map and see if we can reduce the usage of a second for loop. So what we can do is, maybe let me just write and then I'll explain. So what I'm doing, I'll just create a num dictionary, and which is empty initially I'll create. And then what I'll do is I'll just create one for loop. So for x in range, where I'll go till the length of the list, which is nums. Okay. Now, in this dictionary, I'm going to basically put the number I want, okay, and at what index we found that number, okay. What is the number we want, target number, and where we want to find, where we find it, okay. So what I'm going to do is, so current value of the map. So what I'm doing, current map value, okay. What I'm doing is, I'm going to take it as a num dictionary. So what I'm doing is, I'm going to check if this value of num of x is already there as a part of a dictionary. So how we can do it? We can basically use num of a dictionary, okay, dot get, okay, and our key would be nums of key, nums of key, okay. So for what here we are trying to do is num of x. So the first element, that is 1, okay. So we are checking if in the dictionary that one key is available or not, okay. One key is available or not. So it is not available, so it will return none. So what I'm going to do is, if this current map value is not none, okay, if it is not none, then you want to do something. Let's say for now I'll use a pass, okay. If it is not none, sorry, if it is a none, what we're going to do is, we'll come into the else, we'll get the number to find, okay. Number to find, how we are getting it, we have already seen it. It's basically a target minus number of nums of x, okay. So target is 11, 11 minus num of x is basically 1. So 11 minus 1, that's a 10. So number that we want to find is 10. And then what we can do is, we can add that into our dictionary, nums dictionary, okay, of number to find, okay, is equal to, value is number of, in fact, we need to put the index on, okay. We have to just put the index of it. So that's why we are maintaining that, okay. For number to find a 10 number, we are trying to find at index 0. So it is not found there. So now go back, take the next element, that is 3. So now if I do num of dictionary dot get num of, now the next index is 1, right? So at index 1, what is the value? 3. So we are trying to get if 3 value is available in this dictionary as a key. So it is not there, again we'll get a none. So if it is not none, obviously it is not there in the dictionary, okay. I'll just write that dictionary here, what we have written it right now. 10 is the key, value is the 0, okay. So it is not there. So what we'll do is, we'll come in the else, number to find is 11 minus 3, that's a 8. So 8, then what we are doing, number dot dictionary of 8 is equal to x. So 8 colon 1 we are doing. So again, go back, take the next value, that is 7, okay. So now is 7 key available in the dictionary? So it's not available, so we'll get none. So we'll come out of this into else. So target is 11 minus next element 7. 11 minus 7, that's a 4. So number to find is 4. So num of dictionary of a 4. So 4 colon 2. That's what we are going to add it. Again, go back. Next element is 9. So is 9 key available here? Oh, so it's not available. Again, we'll get a none. We'll come here. So 9 minus 2. Sorry, 11 minus 9, that's we are getting 2. So 2 is our key. So 2 is our key. At what location? It is available at the third location, index 3. Okay. Now go back here, and what is the next element? We are getting 2. So is 2 key available in the dictionary? So yes, it is available. So it is now not none, will come inside it. And inside this, what you need to do is simply just return. Okay, what we need to do is return the index, that is 3. So that means what we need to return, current map value, okay, comma, what you need to return? The x. X, that is the current index, is a 4. So 3 and 4 will be returned. That's it. And if out of this 4, nothing is happening, we'll be just returning a null at the end if we are not able to find a match. Okay, so that's how simply we can reduce. So now this time, if you see, if you implement like this, we are just using a one for loop. So earlier we are getting time complexity as n square. Now we'll get only n because we are running through the only one loop. So this is optimized solution because we are reducing the loops. Now here we have only 4 element, right? What if you have thousands of element and if you use 2 loops, it is going to add up a lot of time, right? But now if you use one loop, we are almost kind of getting it in a half time. Okay, so let's write it in the here. Okay, I'll just quickly remove this code and let's try to add it in the same. Okay, so how to add it? We need to first get a dictionary. So I'll just say num dictionary, which is I'm initializing as a dictionary. Okay, and here what we're going to do is first we need to get the current map value, which how we can get it? Num dictionary dot get. How we have to get it? We have to check if nums of x. This is part of that as a key as a part of this list. Okay, and we need to check if CMV is not none. Okay, if it is not none, then only we need to return something, but I'll come back to this later. Let's write the else part first. So in the else part, what we need to do is number to find is we need to first get that's as a target. So target minus nums of x. Okay, so we need to get the number to find, and then what we have to do is num of dictionary of number to find is equal to the index, that is x. That's it. And here what we need to return, here we have to return a list which has first element as a current map value comma x. That's it. Okay, so now earlier we got the time complexity as a, here it is showing that the time it is taking is a 937 millisecond. Okay, now if you run it, we should get a different solution. Okay, first of all run it and see if all the test cases getting passed or not. Okay, so yeah, you can see all the test cases got passed. Now let me just submit it and see the difference here. So it's still kind of testing it. Is it done? Let me just rerun, submit it again. Okay, so now to check. So now you can see earlier we are now the first of all time you can see it's just finishing it at 62 millisecond. And now it's saying you are better than 54% of the people. So earlier we are getting just around a 30, 35. Now we are getting it 54. Okay, maybe if we just keep running it, we'll get a different time. Okay, that should be completely okay because that's all depend on the current usage of their server. Okay, you can see now it is saying 89. You are beating your output is betting 89% of the people. Okay, so that's how basically you can solve it. Okay, so here what important thing we have learned in this video is basically when you get any problem statement, first ask all the constraint. Okay, try to get more information about your problem statement. Once you get an understanding of all the constraint, then you can just first discuss couple of test cases around it. Okay, so that you will get some better idea on this. Once you understood the constraint as well as the test cases, then you should start writing first, target the working solution. Okay, don't directly start thinking about optimized solution. That is something you can take it as a next step. First try to get a working, so it's always better to have a working solution. Okay, instead of uncompleted your optimized solution. Okay, so yeah, that's what you need to remember. I hope this video finds everyone useful. Okay, definitely the problem statement we have given is definitely it's a very simple. We'll keep adding a very advanced level of DSA programs. Okay, but for now, this the agenda for this particular video was to more about how we can tackle or how we can ask the questions to the interviewer and get more clarity. Okay, so that's it for this video. I hope that find useful. If you have any question, please ask in the comments. I'll definitely try to answer it. Thanks, everyone.